So using the properties, that is what we did all of last week. This week, I'm going to shift this slowly so no one panics. Flip your page over in your 5A packet. So right now, we're going to be talking about something we started yesterday. We started yesterday about radicals and indices and radicands. I'm always feel like I'm saying that wrong. Radicand versus radical. No, that's how you call it. And so we're going to go from this symbol, this radical symbol, and combine it into our rules. Now the rules we're going to use that we did a few moments ago, those are going to be the exact same rules that we're going to use. However, now we have fractions. Let's talk about it. The first thing we need to talk about, where did we go? Where did we go? There it is. Hold on. Okay. For radicals. Radicals have their own properties. I'm going to talk to you about the ones that we're going to use the most. There are more properties that will be introduced to you in IM3. We're just talking about a few. One of the first radical properties that we talk about is the exponent, where if you have, I'm just going to do a quick show that that's the radical. You have an index, you have the radicand, like radic and then and, radicand. So properties. When you have an exponent on your radicand, so on the inside, when you have an exponent, give me a number, any number. 4. Actually, you know what? Let's use 4 in a few seconds. Hold that thought. Let's use M. I think that your worksheet uses M, so I want to keep that consistent. That can be rewritten as the entire thing, all of it, raised to that same power. Because sometimes it's easier to simplify something smaller and then raising it to a power versus doing all of that raising to a power and then simplifying. Put your phone away. This is very important. You are quizzed on this in about 2 days. You then have a power, yes ma'am. I would highly encourage you to get into the habit of doing that, because what sometimes happens is, especially like in the higher challenging questions, you don't know if something's inside or not unless it's separated with that little notch. Like on your textbook or your worksheets, textbooks as well, they leave it out. But then some of the questions you don't know what's in it or what's not, so I encourage leaving that little tick mark. I also encourage you guys putting a line through 7 so it doesn't look like a 2, or like put a line through Z so it doesn't look like a 2. Okay, so that's one of the properties. The next property we have is when we have, I think we talked about this yesterday, that beautiful division property, that quotient property. So when you have something like A divided by B, and it doesn't matter what it is, you just have something divided by something, a fraction on the inside. What's really cool with the quotient property is that we can rewrite this as the square root, cube root, fourth root, fifth root, eighth root. We call this nth root because it can be anything. On top, and that same root on the bottom. We can separate it. Now we can also combine it. So this is a double arrow. It can go forwards, it can go backwards. So if I need to combine things to make life easier, do it. If I need to separate things to make life easier, do it. And then the last one we're going to talk about is the product property that says if I have something like A, B, C, D, E, F, G, Q, R, S, W, Z, doesn't matter. You have a bunch of things in there. You can undo that by writing it all out. Now the catch is your index has to be the same when you're writing out. You can't just randomly change your index. And the same thing goes to combining. So A, B, C, D, E. So this is again a double-sided arrow. So if you have a lot of things expanded and you need to put them together, just put them all together. The index has to be the same. Those are the three properties that are going to be really important. There are more properties. However, we are not dealing with them just yet. We might deal with them. We might wait till IM3. Now we have something that's called rational exponents. A rational exponent, everyone say rational. Oh, thank you, my 5 people. Let's try again. Rational. Oh, try again. Rational. Thank you. Rational. Rational is just a fancy way to say fraction. A fraction can look like a fraction, or a fraction can look like a whole number. I claim that 2 is a fraction. Why do I claim that 2 is a fraction? Because it's over 1. Exactly. I claim that 25 is a fraction. So 25 is a rational number, the same way as 3/4 is a rational number. So rational just means fractions. So for example, mathematicians, I see your hand, give me a second. So for example, you know mathematicians are what? We're lazy. So instead of saying, I want numbers that could be fractions or they could be whole numbers, they were too lazy to say all of that, so they created a new word called rationals. Yes, sir, you had a question. Oh, ratio? Yeah, like a ratio. Like something over something, ratio. Do you see that? Boop, ratio. Look at that. I didn't even notice that. Thank you for pointing that out. I had no idea. Okay, you ready? So what do radicals and rational exponents have in common? You ready? You ready? Ready? Okay. Draw a radical. With an index of n, with a radicate of a, with an exponent of m. Just like what we did a few seconds ago, boop, right there. Okay, this is not a rational exponent. This is a radical. So I'm going to do radical. Give it in a little thinking bubble, radical. We want a radical to become a rational exponent. We want to convert it. We say, hey, this weird looking thing with like a tail and I don't know, it looks like a dragon head or a lizard head. Like we don't want that, so we want an exponent instead. So what we do is, you ready? Take your radic and, so this right here, and you're going to copy it down. That is going to be your base of your exponent. I'm going to choose to put it in parentheses, so that way you know everything inside is your everything. Then, do you see this m as your exponent? That m stays as your exponent. So we're going to write m on top. Then, the biggest difference, oh, I had more highlighters, where'd they go? Then, the biggest difference would be this n, this index. This index is kind of like inside. I'm writing it like on top, but it's like really inside. So if you look on your like sheet, you'll notice they're like inside. That n is going to be your denominator. That's your n. So your rational exponent Whenever you see a fraction as a exponent, that means in reality, it was a radical that we didn't want to draw the symbol for. So it goes from here to here, from here, guess what, to here. A double-sided arrow. We can go from the radical format to a rational exponent format, from the exponent format to the radical. We can go back and forth as many times as we need to fit our needs. Sometimes for me it's easier to deal with fractions, but sometimes to me this is easier. So it all depends on what we need for each question. All right. On your 5A packet, I would like for you to flip to this page right here, where it says converting to radical form and converting to exponential form. Converting to radical, it's the second to last page. Okay. I'm going to be select with what we do because some of these questions are easier, some of the questions are more challenging. So I'm going to be selective with what we do. How I'm going to rewrite them is including what we learned last week. So not only am I going to convert them to rational exponents or convert them to radicals, I'm also going to be simplifying by using my exponential rules. So keep that in mind. There's two things that's happening: conversions and simplifications using the properties. Let's jump in on that page. Let's start with something a little bit on the basic side. Let's do number 3. We have parenthesis 15x to the 1/2 power. This is asking us, write each expression in radical form, simplify if needed. So in our brain it says, okay, we have an exponent. That exponent is a fraction. We want a radical. A radical means you got that symbol. So let's write out that symbol. But here's the thing. If you don't want to do that as your first step, you don't have to. You don't have to. If you want to use your exponential property of exponents right here, that power property of exponents, and bring that 1/2 down, you can. That is your choice. I already drew this out first, so that's okay. So I'm going to do 15x. What is my exponent? Oh, careful. Yes, my exponent is 1/2. But when we are converting, what is my actual exponent? Yes, sir. Oh, I swear it's one of those 3 things that you said. It is 1, yes. Think of it this way. 1 is on top, 1 is still on top. So the number on top is going to be the one that's on the exponent, the one that's on top on the exponent. The one that's on the bottom, that's going to be your index because it's here. It's kind of like taking that 2 and like shoving it inside. Yeah. Say it a little bit louder. I'm having trouble hearing you. You meant to say that? It's okay. We'll do another example and you can redeem yourself, I promise. Okay. Do we really need that one? What is 3 to the first power? Anyone? 3 to the first power? 3. What about 4 to the first power? 5 to the first power? You get the pattern? We don't really need this. It's just 1. So this is the rewrite. Now we are in the second step of that question to simplify. So how do we simplify this? Step 1, use the product property, and I'm going to separate everything out. I'm going to say I have 15 squared, and then I'm going to say times x, and again this is square root. And I'm going to check, can 15 simplify? This is what we were doing yesterday. 2 numbers that multiply to 15, but one of them has to be a perfect square. The only numbers I can think of for 15 are 5 and 3. Is there anyone else thinking of a different number that can do 15? 2 doesn't go into 15, but that's not a perfect square. 4 doesn't go into 15. Okay, so because 5 and 3 are not perfect squares, that means we can't simplify 15. So that means we go backwards, we write out our final answer, 15x, and you are done. So this right here was try to simplify. If it works, it works. If it doesn't, it doesn't. Okay, I'm going to jump to number 9. Number 9 is 7, parenthesis, 12w, parenthesis, 1/2. Now I'm going to do something different than example number 3 to show you that you can do this different ways. Like there are many methods for you to, like what your step number 1 is. So step number 1 here was immediately to jump to rewrite. My step number 1 here is I'm going to choose to use my property. I'm going to choose to use that exponential power property that says I'm going to put 12 and 1/2. Ladies, we're doing good? And 1/2 onto w. So look at what I did with that 1/2. I put it onto 12 and I placed it onto w. This is the power property for exponents. So now I have 7 times 12 to the 1/2 power times w to the 1/2 power. Now our goal is still to rewrite this in the format of a radical. Radical is that symbol right there. So let's do that. We have 7 times 12. Oh, here's our chance. Let's redeem ourselves. What is the exponent on 12? 1. 1 is on top. 1 is on top. 2 is our index and it goes inside. Now realistically 2, you don't really see it. You can write it in, but know if there's no number there that it's 2. Oh, and then we got to do our w. W. What's the exponent on w? Oh, 1. But I do see where you got that 1/2. So when we're converting, that number on top is your exponent. That number on the bottom is your index. I'm going to rewrite that one more time. 7 times the square root of 12 times the square root of w. I'm going to remove those ones because they're really not needed. They're just 1. Now at this step is we're going to try to simplify. So what is highlighted right here, what is underlined, excuse me, that's your radical format right now, but it's not fully done. We have to simplify. So I'm going to ask a question. Same question I've been asking. What are 2 numbers that when I multiply them, get me 12, but one of them, one of them has to be a perfect square. Why is it a perfect square? Because we have an index of 2. If we had an index of 3, 4, 5, I hear 6 and 2. Okay, is 6 a perfect square? Yes? What times what is 6 with the same number being the same? Doesn't work. Go for it. 4 times 3. I hear 4 times 3. Absolutely. 4 times 3. We want pretty numbers that we can simplify. So what is the square root of 4? 2. Square root of 3? That's icky. We keep it. If we can't simplify that, just leave it. And don't forget your 7 that we had. 7. So this is right now what we have. We have 7 times 2 times the square root of 3. What's 7 times 2? 14. So we got 14 times the square root of 3. This right here is your final answer in radical format. Yes? What did happen to W? Oh, it's still there. Let's put it there. Boop. Thank you. I'm going to circle it so I showed that it's still there. I forgot W existed for a little while. Thank you for that. Okay. Now let's jump into the second section where it says 10 through 18. We want to write each expression in exponential format. Okay, anyone still need this right here? Going once, going twice. Okay. Again, I'm going to jump into something that's a little bit more challenging. Let's start with 15. We got the everything in parentheses, 3m, and then 7. Now this is in radical format and they want it in exponential. So this is a radical and they want it in exponential. So one thing that you need, let's see if I can find it really quickly. I might not be able to do that. Nope, of course not, because that, oh, I do, right here. Is right here for the exponent. Sometimes your exponent is out in front. Sometimes your exponent is on the inside. So if you wish to move the exponent in before you move it outward, that's fine. But if you choose to do so, make sure that you know that the exponent, because it's on the outside, is on the 3m, like it's on all of it. It's not just on m, so you have to put 3m inside a bubble in order to continue. So we're going to write out our inside, which is 3m. The exponent is 7, so we're going to write it on top. What is our index here? What's the number inside here? What's our index? Oh, try again. What number? What symbol is this? If we were to look at it and say, what is it? It's a square root. Exactly. So we have an index of 2. Now again, we can potentially continue this. We can continue and put the 7/2 onto 3 and put the 7/2 onto m. There's a lot of things we can do. Right now it's just asking us, it's not asking us to simplify or anything, it's just asking us to write it in exponential format. So we are done with that. Let's move on to question number 18. Question number 18 is saying here's the 8th root, because the index is 8, of 9x squared y 12th. And again, this is in your radical format. We want it in exponential. So to convert it, you can do two different things. You can put all of this in parentheses and raise it to a power, or you can separate it and then raise that to a power. That is your choice. So for example, if we were to use one of our properties first, here's our property right here that says, hey, we can just separate things out into its own radical. So this is the one that I'm going to be using. Separate things out into its own radical. So we got 8th root of 9 times the 8th root of x squared times the 8th root of y to the 12th power. From here, we can go into writing it in exponential format. So we got 9. What is the exponent right here on 9? 1. 1's the exponent. The index is 8, so we write it on the bottom. Then we have x squared. The exponent is 2. The index is 8. Then we have 12 as our exponent. 8 is our index. Now, take a look at these two fractions. And note that we actually can go back and simplify the fractions. I have 2 over 8. I got 12 over 8. So 2 over 8 can simplify to 1/4. And 12 over 8 can simplify to 4 goes into 12 3 times. 4 goes into 2 twice. So we can potentially leave our answer like this. And again, it's not really asking us to do much with this. It just wants it in exponential format. So that is okay to leave it like this. Okay. Yes, ma'am.
On the test will it have every single way we've learned so far?
Yes.
First of all.
Yep. You're welcome. All right, let's talk about fractions. On skill packet 5B, I need you to look all the way at the end. And I went ahead and highlighted for you 3 properties of fractions, 3 rules of fractions, 3 directions for fractions that you will be needing constantly. You're going to be needing to know how to add fractions, you're going to be needing to know how to subtract fractions, and you're going to be needing to know how to multiply fractions. when you are adding fractions, that's going to be adding the exponent. So let me zoom in just a little bit so you guys can see and write this out. Found out this little tool right now that we can go in. Okay, so when you are adding fractions, that means you have the same base and you're multiplying that base together, so you add the exponent. So the properties are exactly the same. The only thing different now is we throw in fractions to complicate your life. That's it. So take a moment to write that down. And again, these are the same thing that you're doing when you had just regular integer exponents. Make sure everyone's writing this down. Micah, good morning. Make sure you're writing this down, please. Make sure you're writing this down, please. Give you another few seconds to write that down. That's not much for you to write down. You multiply, you add, you divide, you subtract. You have an exponent to an exponent? Yeah, that's fine. Exponent to an exponent, you're going to multiply. So I'm going to give you an example of how to deal with fractions. So that way when we actually throw them into using the properties and the radicals and the conversions, we're going to be okay. All right, so to add fractions. And I'm going to group adding and subtracting fractions because the steps are the same. Whew, sorry about that. Let me zoom back down so you guys can see more. Okay, so when you are adding, subtracting fractions, step number 1 is make sure you have the same denominator. If you have a different denominator, you have to convert them to common denominators. So in your packet right here that you just had in front of you, it says find a common denominator for the two fractions. Make equivalent fractions and add the numerators. Change the answer to the lowest mixed number if the question requires. So for us, we're going to make sure the denominator is the same. If it is not, we're going to find the common denominator. And I'm going to say convert to a common denominator. So let's say, for example, and I'm going to throw in an example right here. Let's say we have 3/4 plus, I don't know, 5/6. Step number 1 is to look and see if you have a common denominator. 4 and 6, not the same number. So we're going to ask ourselves, what is common between 6 and 4? Anything common? We can multiply by 2. But if I multiply 4 by 2, that will give me 8. 8 and 6, still not the same number. Yes?
You have to multiply by the same number.
You don't actually have to multiply by the same number. You want the output to be the same number, but you don't have to multiply by the same number. We can make them both 12, sure. So how do I make 4 into a 12? By 3. And how do I make 6 into a 12? 2. Perfect. Now keep in mind, if I only multiply the bottom by that 3 and then the other fraction by that 2, I completely mess everything up. So I have to keep things equivalent, meaning I have to keep the value of the fraction the same. So I'm going to multiply top and bottom by 3 and then top and bottom by 2. So I'm separating out these fractions. You got 1, you got 2 fractions. So we got 3 times 3, everyone says 9. 4 times 3 we have 12. Plus 5 times 2 is 10. 6 times 2 is 12. Now that you have the same number on the bottom, don't mind my hand there, 12 and 12, now all you need to do is step 2, add or subtract the numerator only. Basically, do exactly what it's telling you to do. If it's telling you to add, you add. If it's telling you to subtract, you subtract. So in this case, it is asking us to add. So we have 9 twelfths plus 10 twelfths. What is 9 plus 10? 19. We got 12. 19 is prime. So we are done. I'm going to box this up and I'm going to say simplify if possible. Simplify if possible. So if you can, just like we saw in the previous example, we were able to simplify, what was it, 12 somethings. 12 eighths. So 12 eighths was able to simplify, so we just simplified it. So that's how you add and subtract. Find the common denominator, make the denominator the same, add, subtract. Now when you're multiplying, I always tell my kiddos you can multiply fractions with one word, across. That's it. That's it. Just multiply across. Simplify, multiply across, you're done. So let's say with the same numbers, we had 3/4 times 5/6. Or you're going to see 3/4 times 5/6 like this with the parentheses. Either way, what you're going to do is you're going to multiply the top. Step 2, multiply the bottom across, right? I don't want to add that there, but you're going to multiply across. And then step 3, simplify if you can. So what's 5 times 3? 15. 6 times 4? 24. Can we simplify that? Yes, we can. What goes into 15 that also goes into 24? 3. You're absolutely right. I hesitated there for a second. I'm like, really? They can't? 3 goes in there. 3 goes in there. So 3 goes in there. 5 times. 3 goes into 26. 6 times? 8 times? You're absolutely right. And so we have a simplified fraction. Yes? Not right now. Okay. So far we've done a lot today. We started out the lesson with reviewing our rules, our exponential properties. Then we talked about converting. So I'm trying to get all my paperwork here. So we started out with this example right here where we reviewed our properties. Then we said, hey, these are radicals, and we can convert radicals into rational exponents, and then we can do rational exponents into radicals. Then we said, okay, here's our examples of converting. Here's more examples of converting. And then at the end, I threw in fractions. And guess what? We're still not done. I still have more. Okay, still have more. The last thing, I promise. You ready? Okay. On your skills packet, 5A, turn your page over to this right here where it says simplify expressions with rational exponents. And on this one, it is asking you to do a few things. It's saying step 1, rewrite all radicals in exponential format. So it's asking you to convert. Step 2, use the exponents rules to simplify. Step 3, bring it back to a radical simplest form. So we got a few things to do. Okay, you ready? So let's try number 20. Number 20. We're going to take this a little bit on the slower side. Number 20. P to the 1/4 power times P to the 3/2 power. We have a base of P. We have an operation of multiplication. So if we have the same base that we're multiplying, what happens to the exponents? What happens? We add. So now we say P 1/4 plus 3/2. Okay. We're dealing with fractions. We need to add. Step 1 with adding fractions is you need to make sure the denominator is the same. We got a 4 in the denominator, we have a 2 in the denominator. Are the denominators the same? No. How do we make 4 and 2 be the same? Multiply by 2, I hear. Make them a common denominator. So that means now I have P to the 1/4 plus 3 times 2 is 6. 2 times 2 is 4. Do I have the same denominator now? Yes. So step number 2, when you're adding, subtracting, you are then going to add, subtract, whatever you need to do to the numerators only. So in this case, we are adding. So we are saying P to the 6 to the 7/4 power. Okay. This right here, I'm going to put a box around it and call it exponential form. It's not asking for exponential form. It's asking for the simplified radical form. Okay. I'm going to teach you a trick. You ready? Okay. Rewrite what you just wrote. 7/4. P to the 7/4 power. When it's talking about simplified radical form, it's saying you got to pull stuff out that doesn't belong inside the radical. There are things that can simplify. There are things that you can pull out. Like if I have a square root of 16, I'm not going to write the square root of 16. I'm going to write 4. It's simplified. So what happens here is we need to separate things out. So watch what happens. I want a pretty number on top that is less than 7, that when I divide by 4 will give me a whole number. I'm going to repeat that. I want a pretty number that is less than 7, that when I divide by 4 will give us a whole number. What do you got? 4. I hear 4. Okay. Let's see if we got 4. What is 4 divided by 4? 1. Okay. But we don't have 4. 4 is kind of random, right? What did we have? We had 7. So 4 plus what is 7? 3. So that means, watch what happens. This P can simplify to just 1P without any fractions. This P can simplify to P to 3/4 with a fraction. Okay, do you see how that happens? This guy right here has a fraction. Anytime you have a fraction in the exponent spot, that means it's a radical. That means you have this symbol here. p is on the inside, that's our base. The exponent is 3. The index is 4. However, we still have this random p right here that we simplified because it does not have a fraction attached to it. You place it on the outside of the radical. So this right here in this box is your simplified radical form. Okay, let's do it again. You know what, beautiful people, I just realized the time we are done for today. I'm going to start packing up. Thank you.